The launch of a rocket that delivers a satellite from rest to a speed of over 28,000 kilometres per hour at an altitude of a few hundred kilometres is an impressive sight. But did you know that the mass of the final payload that's placed into orbit is only a few % of the mass of the rocket just before it takes off? The rocket's so heavy because it has to carry with it all of the oxygen to burn with the fuel. So we need a very big rocket to launch a very small satellite. We know that there's plenty of oxygen in the air through which the rocket is flying, so why don't we use that oxygen to burn the fuel, just as we do in a car's engine, where we burn petrol in air, or in a jet engine, where we burn jet fuel in air. What we need is an air-breathing engine that travels at really high speeds. This is where the idea of a scramjet comes from, and being able to understand what happens to the flow in and around a scramjet is the destination for the journey that we'll take in this course. We'll start by looking at the flow of gases at speeds higher than the speed of sound. This will lead us to shock waves. What is a shock wave, and when does one form? And what changes are there to the properties of the gas as it passes through a shock wave? We'll find out in this course. Then we'll increase the speed and look at what happens when the flow is hypersonic, more than 5 times the speed of sound. Then we'll be ready to look at that air-breathing engine flying at hypersonic speeds, the scramjet. In the course, we'll use data from some of our hypersonic shock tunnels and from some of our computational fluid dynamics simulations to see what happens in hypersonic flows. The teaching team has lots of experience in hypersonics. Some of us have been researching and teaching in the field for more than 20 years. But we've got some younger chaps too who are going to be the ones, maybe with you, who'll develop the hypersonic systems to allow us to access space using scramjets. So if you have some background in calculus, introductory fluid mechanics and some thermodynamics, fasten your seatbelts and let's take off.